Alrighty folks, today we're looking at graphs of sine and cosine. Now graphing trigonometric functions of sine and cosine are going to be similar to graphing normal functions. We're still going to use an xy plane, but we're going to do things a little differently in terms of where the values are coming from. So to start things off, we have our sine. The sine value is typically the y values of our unit circle. Let's say our zeros, 1/2, going around our unit circle. But we're not going to worry about all 16 of these angles. Rather, we're only going to focus up on 5 of them. And you might have noticed I said angles. With regard to our x-axis is going to be composed of the 5 angles that we're going to care about. The 5 angles, whether for sine or cosine, are always going to be the same. They're going to be 0, 0 pi. They're going to be the endpoint, 2 pi. There'll be the halfway point between them, pi. The midline between 0 and pi, or pi over 2. And the midpoint between pi and 2 pi, also known as 3 pi over 2. Now we just look at our sine values. The sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is 0, giving us a sine curve that's kind of like a gently rolling hill and a valley below it. And because our unit circle extends infinitely in rotations, so too does our trig graph extend infinitely in both directions, just repeating this same pattern of hill, valley, so on and so forth, over the period of 0 to 2 pi, or a period of 2 pi. So my graph here has a domain, which is going to be negative infinity to positive infinity. It has a range, negative 1 to 1, because those are the highest and lowest values of my sine values. And then we're going to have what's known as the period. The period is how long does it take for us to do one complete rotation. Period of a circle, that's 2 pi. For our purposes for now, we're always going to have a period of 2 pi. We're not going to mess with our periods just yet. Sine is going to follow a very similar process. The sine, well, that was usually our x values on the unit circle. Now x is in quotation because they're still going to be our output values, but they were the x's from our unit circle. We're still going to have our 5 key angles of 0 pi, 2 pi. In the middle we have our pi. Between 0 and pi we have our pi over 2. And between our pi and our 2 pi we have our 3 pi over 2. But now, since we're looking at the x values, at 0, the cosine of 0 is positive 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is once more 1, giving us a slightly different curvature. Now folks, a number of people might refer to this as a parabola. It is not a parabola. Parabolas, if you recall from marking period 1, extend upwards or downwards infinitely. This is going to bound once more into another steady waveform. It's not a parabola, it's a cosine. So we have our domain. Domain for a cosine is going to be the same as sine. Negative infinity to positive infinity. Range is going to be the same as sine. Negative 1 to 1. Period is going to be the same as well. 2 pi. partially because we're not messing with our periods, and partially because that's the amount of time it takes, the amount of units it takes to make our one little valley between these hills, going from 0 to 2 pi. Now, important note here, there's no reason we have to start at 0. We can start wherever we want to, provided we end 2 pi units away. More on that a little later. Now, just like with our normal graphs, we have our transformations. And we have a general form where each letter here has a different value. Back in marking periods 1 and 2, the A value was essentially a vertical stretch. This either made things longer or made things more compressed vertically. The B value, that was a horizontal stretch or compression. So stretch or compression, whether horizontally or vertical, were at A and B. Our C value, that was a horizontal shift, moving things left to right. Whereas D was our vertical shift, moving things up and down. For our trig values, the properties are going to be the same, but we're going to call them slightly different things. For our transformations, our A value is now replaced with what's known as the amplitude. The amplitude, if given a simple waveform, in this case a sine, the amplitude is the measurement from the highest point to the midline to the lowest point, or 1/2 the distance of the overall height. Now, amplitude is also always an absolute value. So in a way, it's always going to be positive. But if we have an A value that is less than 0, that means that we're going to have a reversed graph, that instead of going up, we're going to go down, or whatever, as needed. The B value governs our period. The B value can still stretch or compress things horizontally, but stretching or compressing them horizontally is now manipulation of the period. In terms of degrees, that's going to be 360 divided by B. In terms of radians, that's going to be 2 pi divided by B. A large B makes the period smaller. A big B makes the period a large b makes the period smaller, a small b makes the period larger. So if b is greater than 1, we're compressing things. If b is less than 1, we're expanding things. Again, for now, we're not going to go into period manipulations, but I'm giving you the information just in case you need it. Phase shift. This is what we called our horizontal shifts. Now, bear in mind, our phase shift, or horizontal shift, is acting on the x value. And just like that b value, so the b and the c values here, just like they were in marking period 1, they fall under the rule that the x's lie. Or if you want to think about it in terms of more mature manners, those of you who might have x's yourselves, the x's lie. Personally, I think the second one's a little funnier. More students remember it the second way, but x's lie either way. Whatever the b value is, wherever the c value is, we're going to do the opposite when it comes time for our graph. Vertical shift is still a vertical shift. No new fancy name there. Why the new fancy names? Well, these waveforms, sine, cosine, tangent, secant, cosecant, cotangents, they all show up again in various forms of engineering, geology, and architecture. And as such, we use the more technical names you might encounter in your future. Vertical shifts, I guess, are the unloved ones. But you can use the amplitude, period, phase shift, vertical shift, or you can use the horizontal stretch, horizontal shift, vertical shift, entirely up to you for my class. So let's take a look at this equation here. We want to graph 2 sine theta on our graph. Now, I'm going to only do one period on this, and I'm going to use a scale here where every second one is 1 unit. So 1/2, 1, 1.5, 2, to show how stark this shift is going to be. Now it's a sine function. So starting off, I'm going to start with my sine function that runs from 0 to 1 to 0 to -1 to 0. Give me my little curvature there. But now we're going to take all the outputs and multiply them by 2. So 0 times 2 is still 0, but at pi over 2, what was 1 is now 2. 0 is still 0, but at 3 pi over 2, what was -1 is now -2. And 0 is still 0. So we go to graph and connect our dots. We end up with a much steeper graph overall. Our domain doesn't change though. Our domain is still -infinity to positive infinity. Our range has changed. Now our lowest value is -2, our highest value is -2. Therefore, our range is -2 to -2. Sorry, -2 to +2. All inclusive. Amplitude. Our amplitude has also changed. So the amplitude is the distance from our highest value to the midline, which in this case is now 2. It was 1 before, but now it's 2. Period. Our period doesn't change. Our period is still 2 pi. We ran from 0 pi to 2 pi. Phase shift, none. Vertical slide, none. Sine of theta plus 2. So here we have a manipulation of our d, of our vertical shift. So everything we do is going to go up 2 units. Now for this one, I'm going to go with a scale of 1. Let's say that this will be 1, 2, 3, 4, just to make sure everything is on the same graph. So my base function of sine theta, 0, 1, 0, -1, 1, 0, gives us our general curvature therein. But now we're going to take everything and move it up 2 units. So what was 0 is now at 2, what was at 1 is now at 3. 0 is now 2, -1 is now 1, and 0 is now 2. So I go to connect my dots. I have the same shape, just shifted up 2 units. My domain is still going to be -infinity to positive infinity. However, my range has changed. And here is where people might fall into a trap. The range now is +1 to 3. Do not make the habit of saying something like -3 to 3 or -1 to 3. Our new low point now exists at 1. Our new high point now exists at 3. Amplitude. While we have moved everything upwards, the midline moved up by 2. But the distance between the high point 3 and the midline is still 1. So that hasn't changed. Same with the period. The period is still going to be 2 pi. Phase shift, we've not moved this left or right. Our phase shift is simply going to be not applicable. But we did have a vertical slide. We moved up 2 units. So I would accept up 2 units, plus sign 2 units, up arrow in 2 units. Any of those would work to show that everything got moved upwards by 2. All right, -2 sine theta. So here I'm going to revert back to my previous by 2's, wherein this is 1, this is 2. And we have our base form of our sine at 0, 1, 0, 2, 0, 1, 0, -1, and 0. Connect our dots, we get our nice little curvature going. But now we're going to multiply everything by negative 2. 0 times negative 2 is still 0. But that 1 times negative 2, that now becomes negative 2. 0 times negative 2, still 0. Negative 1 times negative 2, positive 2. And 0 still. Now when we connect our dots, we have basically the reflected and stretched version of our graph. So when it comes time for the domain is negative infinity, positive infinity. That hasn't changed. That will never change. Our range does change though. Our range, our lowest value is down here at negative 2. Our highest value up here is at positive 2. So our range is negative 2 to positive 2, all included. Amplitude. Our amplitude has changed. Our amplitude is the distance from the midline to the lowest point, or the midline to the highest point, or half the total distance. And remember, our amplitude is always going to be positive. But I will accept either negative 2 or 2. Technically, 2 is the more correct answer because it shows that you did the absolute value and got your absolute value of 2. But why will I accept a negative 2? Well, maybe you need the reminder, or maybe you want the reminder for yourself that we're flipping things across the x-axis. So I would accept either an amplitude of negative 2 or 2. 2 is more correct, but if you want to put the negative in to remind yourself that you flipped things over, that's fine as well. Period. Our period here is still 2 pi. Phase shift, no phase shift occurred. Vertical slide, no vertical slide occurred. All right. Y equals cosine of theta minus pi. This is manipulation of our c value. The c value affects the x value, or in this case the angle, and the x's lie to us. So we're going to have to do the opposite of what that says. Now I know that normally if I run from 0 to 2 pi, I'm going to end up having to add pi to everything. So I'd end up at 3 pi. My graph doesn't go out to 3 pi. So this is where that thing I was mentioning a few slides back, where we can start with whatever value we want, provided we have a proper period. Since I know that I'm going to go off screen on this, I'm instead going to start my graph not at 0, but rather I'm going to start my theta at negative 2 pi. That'll make my end value 0, halfway between them, negative pi, halfway between negative 2 pi and negative 2 pi and negative pi is at negative 3 pi over 2. Halfway between negative pi and 0, that's going to be our negative pi over 2. Do our outputs, f of x. Well, I'm still going to have my values of 1, 0, negative 1, 0, and 1. So my graph is still going to look something like this, at least as far as the parent function goes. Same curvature, just moved to the left to accommodate for our transformation. Now bear in mind, folks, I still have my period of 2 pi, which is why this is okay. So now we're going to do our modification, our transformation. That minus pi is going to be a plus pi because the x's lie to us. So what was before, oh, it doesn't want to erase. Okay, so we're going to have to do things the harder way. Do whiteout, digital whiteout. All right. So what was before negative pi over 2 is now, sorry, what was before negative 2 pi is now going to be negative pi. What was before negative 3 pi over 2 is now negative pi over 2. What was before negative pi is now going to be 0. What was before negative pi over 2 is now going to be normal pi over 2. And what was before 0 is now going to be pi. So when I graph my transformed equation, my shifted equation, it's going to look something like this. Same curvature, just that everything got moved pi units to the right. So my domain is still going to be negative infinity to positive infinity. My range is still going to be negative 1 to 1, all inclusive. My amplitude is still going to be 1. My period is still going to be 2 pi. But now my phase shift, well, I've moved plus pi units. I would accept plus pi units to the right, or little arrows to the right with pi. Any of those would work for me. Vertical slide, no vertical slide. But yeah, folks, the reason why I moved the orange graph back a bit was because otherwise we would have ended off page. Just one in the assignment where it says 1 period, that is there. So just in case you know that you're going to end up off page, you can shift things backwards or forwards as needed to ensure that your 1 period is there on the graph. All right, one. Now we've got the sine of theta plus pi over 2. This one I know is not going to put us off graph. In fact, we're going to move in the opposite direction because our transformation, that positive pi over 2, the x's lie. Instead of moving to the right, I'll be moving to the left. So we're going to start off with our thetas. Normal thetas of 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now our f of x, this starts off at 0, goes off to 1, comes back down to 0, goes down to negative 1, goes back up to 0 to give us a little hill and valley curvature. Now, we take our plus 2, or plus pi over 2, so all of our thetas do the opposite, so minus pi over 2. So 0 minus pi over 2. Right, now it wants to raise a little bit. Yeah. 0 minus pi over 2 will give us a new value as we subtract pi over 2 from all of these existing values. So, instead of 0, we're going to end up at negative pi over 2. Instead of pi over 2, we're going to end up at 0. Instead of pi, we're going to end up at pi over 2. Instead of 3 pi over 2, we're going to end up at pi. Instead of 2 pi, we're going to end up at 3 pi over 2. I've written it out that way because I don't want to hit the other buttons on my touchscreen in case things go wrong. So when it comes time to graph these out, everything got moved a little bit to the left. So starting at negative pi over 2 and 0, then going up to 2, we have a 1, down there, back there, to give us this little curvature here. Still got our hill and valley, but just shifted a little bit back pi over 2. So our domain comes out to be negative infinity, positive infinity still. Our range comes out to be negative 1 to 1 still. Our amplitude, brackets, amplitude is still going to be 1. Period will still be 2 pi. Phase shift, we've now moved left pi over 2. So minus pi over 2, left pi over 2, a left arrow in pi over 2, any of those would work. Vertical slide, none. The last thing I want to talk about here. As mentioned, our domain is negative infinity to positive infinity. These graphs continue on forever in both directions. If I extend my red graph a little bit, just a little bit, I'll do that in orange here, the next major point would exist at 2 pi. It'd be right there, a value of 1. Because after that 0 comes out 1. If we extend that out, when we take a look at just this portion here in gray, what we have there is essentially the cosine graph. The sine and the cosine graphs are separated from each other by pi over 2. Sine and cosine, let's say the sine of theta plus pi over 2, that's the same as a cosine graph. Same thing if this were a minus, or if this were a cosine. If this were cosine theta plus pi over 2, that'd be the same as a sine. Cosine theta minus pi over 2, that'd be the same as a sine. Cosine and sine are separated by pi over 2 units. That's the biggest pattern of our unit circle. So folks, as always, if you have questions, please ask. Otherwise, you should have enough to do the assignment on amplitude changes and phase shifts.